In our last video, we were talking about this whole business with I and I squared, all that fun stuff. But I want to talk to you about, like, what if you go beyond I squared, like I cubed, I to the fourth, I to the 20th? What do you do about that? All right, so the first thing I want to show you is how you can think about I like a clock. So we're going to let the top of the clock be I to the 0, just because it's easy to start counting with 0. So anything to the 0 power, if you recall from Algebra 1, is equal to 1. So that means every 4 rotations would get us back to 1 because I squared is equal to -1. So if you take -1 times -1, you get back to +1. So therefore, every 4 i's gets you back to 1. So in regards to the clock, at the top, whether it's I to the 0 or I to the 4th, they would both equal 1. And the next round would be I to the 8th, I to the 12th, I to the 16th, I to the 20th. So every 4 rotations, you're getting 1. All right, so if we started with I to the 0, then this guy right here would be I to the 1. Well, anything to the 1 is just itself, so that's just I. And then I squared, we learned that that's -1. After that is I cubed. Well, I cubed would be an I squared with an I to the 1, because you would have 3 of them. So if you multiply I times -1, you get -I. So everything that we do after that is just going to keep circling around this clock because it's going to repeat the cycle. So anytime we go like I to the 5th, well, that's just 1 rotation after I to the 4th, so that's the same thing as I to the 1st. I to the 6th, well, that would be I to the 4th plus 2 more, so that would put you back at I squared. So we're just going to do a little practice with that clock rotation business. All right, so if you know your multiples of 4, that makes this really easy. So I to the 8th, for example, I'm going to put my clock up here so it's easier to keep track of. Well, 8 divided by 4 is 2 with no remainder. So another way of saying that is a remainder of 0. So whatever my remainder is, that's the exponent I'm looking for. So therefore, I'm going to look at I to the 0 on my clock, but that's just 1. So therefore, I to the 8th is just 1. So if I take I to the 10th, well, I'm just going to divide out all the 4s because every 4 just repeats. So 4 goes into 10 2 times, but you're going to have a remainder of 2, right? Because 2 times 4 is 8, and 10 minus 8 is 2. So therefore, that would be the exponent of where I need to go on the clock. So I squared is where I would end up on the clock, which would be -1. So I to the 10th is just -1. So you put -1 right here. All right. Now we could do the same thing for 15. We could do 15 divided by 4. However, I think it's easier if you think of it the opposite way. Like, I know 16 is a multiple of 4. 15 is really close to 16. So if I gave you I to the 16th, you would be back up here because 16 divided by 4 works. Well, 15 is 1 before that, right? So it's just 1 before it. So I'm just going to go backwards on the clock 1 space. So right before I to the 4th is I cubed. So I'm going to end up at I cubed. So -I would be the answer for that one. And I'm kind of thinking the same thing for I to the 35th. Like, I know that I can do 36 divided by 4. So if it was I to the 36, I would be right up here. So if I take it back 1 and make it I to the 35th, it's -I. Now, see, I have it in my head, I know 64 is a multiple of 4. So I'm just going to, if it would be 16 revolutions, but I'm going to end up right back here. So it's going to be 1. All right. I to the 9th, now I know that that's just 1 more than I to the 8th. So I to the 8th would be up here. 1 more than that would be right here. So there's a lot of different ways to do this, and every kid's different, so you just have to figure out, like, does it work better for you to just do like the division and use the remainder technique to figure out what exponent you're actually at? Or does it work better for you just to think, okay, what's the closest multiple of 4, and I'll just either go backward or forward from there. Like 201, I just off the top of my head know that you can do 200 divided by 4 because, well, you can do 20 divided by 4, and 200 is a multiple of 20. So I know that I can do 200 divided by 4. So I'm just going to go to the top and one more beyond it. That would put me at 201. So it's just going to be I. All right. Now, like 62, I know that 64 would put me at the top of the clock. 62 is 2 before that, so if I'm just going to go backwards 2 spaces, that puts me at -1. So that's how I do it. But you could also do 62 divided by 4. You're going to get a remainder of 2, so you're going to have I squared, which is -1. So a whole bunch of different ways to do the higher powers of I. You just have to play around with it. But it really does help if you think of it like a clock and decide, like, okay, if I kept moving this many, where would I end up? All right, so the last thing I want to talk about is what to do when you have fractions. So you have to remember, since I is equal to root -1, having I in the bottom of a fraction would not be okay because you have a root in the bottom, technically. We're not allowed to have roots in the bottom of the fraction, right? So we're going to follow the same rules that we would for any other problem where we had a radical in the denominator. So like if this was a root 2 down here, you would multiply the top and the bottom by that root. We're going to do the same thing here. So if I see I in the bottom, I'm going to times by I top and bottom. I'm going to use my multiplication rules, and I treat I like it's an x. So 5 times x would be 5x, so it's 5i. X times x is x squared, so in this case it's I squared. And the only difference is if I get I squared, I change that into -1. And 5 divided by -1 is -5, so the answer is -5i. Right. Now, if I have a plus or a minus in the denominator, that makes this a little harder. Right? We learned that we have to use a conjugate for those situations. So I would have to use 3 minus I top and bottom for this, which means I'm going to have to distribute. So 2 times 3 is 6, 2 times I is 2i. Now on the bottom, I technically have to FOIL, but we did learn a shortcut because the insides would cancel out. So we only end up multiplying the first terms and the last terms. So 3 times 3 is 9, I times I is I squared, and it would be negative. But again, we need to change I squared into -1. Now I'm doing this in my head. 9 minus -1 is 10. Reminder, we can't do 6 minus 2i. They're not like terms, so we can't do anything with that. The only thing I look is if all 3 of these have something in common, and they do, I can divide them all by 2, so I will. Right, now I'm done with that problem. So that's what we're going to do. Just practice those a couple times. Some of them need conjugates. I see one on here that does not. So it looks like number 1 is definitely going to need a conjugate because of the minus sign. So that's our first step. Up top, we're going to get 30 and 6i. On the bottom, we're going to get 25 and -I squared. And it helps if you can do this part in your head. You're always going to get I squared, so it's going to be -1. So you're always going to be doing 25 minus -1. That will go up to 26. And then I look to see, do they have anything in common? And they do. They all can be divided by 2. And then I'm done. And I'm going to do the same thing for number 2. So again, just to get that practice in. Now I'm going to shortcut it a little bit. I'm not going to write the I minus 2. You can write that on your paper. I'm trying to save a little time on this video. You would get 4i minus 8 and I squared minus 4 from that. So when I see I squared, I think negative 1. Negative 1 minus 4 is negative 5. Now there's nothing that all three of these have in common, so there's nothing more I can do with that problem. Now, when I look at number 3, there's no plus or minus in the denominator, so no conjugating. That's nice, that makes it easier. I see two issues. 6/10 reduces, but I also have I in the bottom. So it doesn't matter which order you take care of them, they just both need taken care of. So I'm going to choose to take care of the I in the bottom first, and I'm going to use my multiplication rules. So outside times outside, so the 6 and the I stay on the outside, the 3 stays on the inside. These I's would make I squared, and the 10's still hanging around. I always want to swap my I squared out for negative 1. I want to do that right away, which negative 1 times 10 is just negative 10. Now I have to reduce 6/10 and make that 3/5, and then I'm done. Right? There's nothing more I can do with that problem. Right, we'll do one more for practice, and then we should be good on the I thing. So we're going to conjugate because there's a minus. When we distribute the top, we're going to get 8I, and it should be positive 24 there. I have a little typo. I'm going to fix that real quick. On the bottom, you just want to be careful. 2 times 2 is 4I squared. And 6 times 6 is negative 36. And then we're going to swap out that I squared for negative 1, which turns our 4 negative. All right, I'm going to add the bottom two together to make negative 40. And then I look to see, do they have anything in common? And they can actually all be divided by 8. So that's what I'm going to do. So my final answer would be I plus 3 over negative 5. So that's how we're going to handle our I's. All right, it's a new number, and we're just going to roll with it.